Today we're going to solve problem 2428, maximum sum of an hourglass. So let's just go ahead and get started with this problem. This is a medium, so it should be pretty approachable. Hopefully we can have a pretty quick, efficient solution to this. I love grid problems. I think these are usually either graph problems or they're, multi-pointer problems, or they're kind of problems that test that you understand the language well enough to deal with kind of weird situations where you have to look at multiple locations inside of a grid. All right, so you're given an m by n integer matrix grid. We define an hourglass as a part of the matrix with the following form: A, B, C, D, E, F, G. Return the maximum sum of the elements of an hourglass. Okay, so an hourglass is found in a 3x3 square where you sum up the elements and you disregard these two. Note that an hourglass cannot be rotated and it must be entirely contained within the matrix. Okay. All right, so let's go ahead and copy this solution here. All right, so this is me trying to make a 4x4 matrix quickly. Apologize that things don't always reach the edge. All right, and then, let's make this really nice here. There we go. All right, and then we had the value 6213, 6213, 4215, 4215, 9287, 9287, 4129. Okay. So this is saying that the maximum exists at 6212928. So this hourglass represents the maximum. Now, in this kind of problem, we really have no choice but to check every possible hourglass because we're not given any other information about the grid. So we're just going to have to check every single hourglass and return the maximum. Now, since the hourglass has kind of like tabletop length, of 3, like the width of it is 3, and it's not a variable length, we don't need to do anything like a prefix sum or try to keep a running count of how much is before or how much is after to limit, over counting because the length is only 3, right? Since the length is only 3, what we can do is check the first hourglass, right? And then we'll just go ahead and check subsequent hourglasses, right? So this here in green, this is another hourglass. Remember the note saying that it can't go outside of the bounds. So this would be the next hourglass. And then finally, this is the final hourglass in this system. So this is really just a problem trying to check if you do a loop, how can you make sure your bounds are right? How can you make sure you're within bounds? So what I'm going to think of is, well, all these hourglasses, like we said before, they're just inside of these 3x3 grids. So how many 3x3 grids can we draw? And where do they start? Right? So there's a 3x3 grid here, and it starts at 0, 0. There's a 3x3 grid here, starts at 0, 1. There's another 3x3 grid here, and it starts at 1, 0. And there's a final 3x3 grid here, and it starts at 1, 1. Right? So there's only really 4 places where we have to check for an hourglass, right? 4 places to start. So of course our grid starts at 0, 0, and it's going to end at m-1, n-1. Right? That's the final index of our grid. So we want to make a loop such that we go through here and here and here and here. So we want to make a loop that the last index is 2 before. The last index is 2 before. Notice this whole space here. This is a buffer of size 2 in each direction, right? It's always 2 below the end of the array, and it's always 2 to the left of the end of the array. All right, so let's go ahead and do that. All right, so we want to go I in range, length of grid minus 2, and then 2 in the other direction, length of grid minus 2. Since it's not necessarily square, we need to do that. And then let's just print ij to kind of show what's going on here. So this should print 0, 0, 0, 1, 1, 0, 1, 1. Right? 0, 0, 0, 1, 1, 0, 1, 1. So why am I saying all that? Because we look at this index, and this index, and this index, and this index only. Now when we're inside of that index, what do we have to sum up? Well, let's just say, for example, that we're dealing with this case here. Okay, so for this case, we have I equals, I equals 1, j equals 1. Okay, so how do we sum up the hourglass with respect to I and j? Well, the first thing we need to sum up in our hourglass is this area here. So that's the sum of the grid at I, right? Because that'll get us the I row here. From j, right? Because j will get us to this location here. To j plus 3. So the next 3 values. Okay? Similarly, how do we get this information? Well, that's just the sum of, well, if I is here, then I plus 2 is here. So that's the sum of the grid at I plus 2 of, well, the same situation, j to j plus 3, right? And then finally, we need to get this single element here, and that is just the grid at, well, with respect to I is plus 1, with respect to j is plus 1. Grid of I plus 1, j plus 1. And then we add these things together, right? So that's the whole system with respect to I and j. So we've already found a way before to move I and j to these indexes, right? So when I and j is 0 to work here, to work here, to work here, et cetera, et cetera, et cetera. So we just have to return the max case of this. And that's the solution. Okay, so we'll say m equals 0 for our max. We'll say m equals the max of m. So maybe there's a previous solution that's larger. And then there's a... what am I doing? Let me just look at my... Okay, so we have sum of grid of I to j plus 3. I'm just copying exactly what I did before. Plus the grid at I plus 1, j plus 1, right? Plus the sum of the bottom part of the hourglass, which is I plus 2, j to j plus 3 again. Oh, j plus 3, I plus 2. And then we do that for each grid, and we return the maximum such m. Come on. All right, let's submit that. All right, cool. And then if you look at this, you'll notice, well, there's actually a one-line solution if you want to get fancy with Python, right? Which may make it more confusing, but we could say the maximum of this, we'll close the max down here for now, for I in range, length of grid, minus 2, for j in range, length of grid 0, minus 2. And now we don't need any of these looping structures. Well, we're using a looping structure, but we're kind of encapsulating it all in one line. So let's see if that works. Maybe this can't be on another line. Oh, always forget return, huh? Like a fool! All right, cool. There you go. One line solution to a medium problem done in a few minutes. Thank you. Have a good